Hello! Today we are going to learn how to convert units with the factor label method. This method is an important method because we will use it all year long in chemistry. As far as converting miles to kilometers or minutes to hours, some of these are problems that I know you could do in your head. What I'm concerned about is you learning how to do the method. So please concentrate on learning the method. Alright, so in our example we are going to convert 10 miles, abbreviated as MI, to 10 kilometers. And the first step is always to determine the units that we want to be converted. I need to change the pen color. It's yellow. Sorry. So we are going to convert miles to kilometers. Then we need to figure out how many miles there are in the kilometer, or how many kilometers there are in a mile. This is something that will usually be given to you. In this case, it's written right here. There are 1.6 kilometers and 1.0 miles. These two steps, you don't have to write anything out. Sometimes you might, but in this case, you don't really need to write that out. The first real step is that we need to write down what it is we're trying to convert. In this case, we are writing down 10.0 miles. That's what we know, and it's what we're trying to convert. So now we're going to create a fraction with that equality, and we're going to put the unit that we want on the top. So we're trying to convert miles to kilometers, so we want units of kilometers. So kilometers are going to go on the top for our equality, and that leaves miles on the bottom. With the equality, it always gets made into a fraction, and you can either have 1.6 kilometers on top of 1.0 miles, or you can flip it and you can have 1.0 miles on top of 1.6 kilometers. And this is the key to the factor label method, is setting up this fraction properly. And over here in the instructions we have a little nifty setup, if you will, and it's all about the units. So the units that you know go out front. In this case, that's miles. The units that you want, kilometers, go on the top, and the units that you know, once again, go on the bottom. So know, want, to, know. Alright, so now we can do the math. But when you look at this, we don't normally write in the multiplication sign, except you should, because that makes it much easier to figure out what we're doing. So we're multiplying 10.0 miles times 1.6 kilometers divided by 1.0 miles. Okay, kidding. What we're really doing is multiplying fractions here. So we're going to put 10.0 miles over 1, and that makes it a little easier to see. When you multiply fractions, you multiply across. 10 times 1.6 is 16, and that's divided by 1 times 1, which is 1. So 16 divided by 1 is just 16. As far as our units, miles times kilometers ultimately got divided by miles. So miles gets canceled out, and our units are kilometers, which is good because we wanted to convert 10 miles to kilometers. So if we ended up with anything other than kilometers, it's a good sign that you need to check your work. So we've done the math, we've canceled out our units. Lastly, we need to round our answer to the proper number of significant figures. So we started out with 3 significant figures, 1, 2, 3. Our answer currently only has 2, so we are going to rewrite our answer as 16.0 kilometers. And that's it for the factor label method. However, if you are feeling ambitious, there are usually multiple steps with factor label method. So let's go on and look at the next slide. Alright, so a two-step factor label conversion. Oftentimes you will find that you need to do the previous step twice to find the answer that you're looking for. So you're welcome to do it twice. It will get you the right answer. However, if you are comfortable with the factor label method, or as you gain comfort in it, you will find that it is quicker to write it out in one step as opposed to doing the previous slide, as opposed to doing that twice. So with a two-step conversion, same thing really. We want to convert 10 pounds to grams, so that's what we're looking to do. Determine the equalities to link the units together. Well, let's see. I know that there are 2.2 pounds in 1 kilogram. Oops. And I also know that 1 kilogram has 1,000 grams in it. So when that happens, we have two equalities for our problem. So we are going to end up needing to do a two-step conversion. Not a big deal. So we're going to write down the number and the unit that we want to convert, which is 10 pounds. And then we need to start with one equality and set that up. You are going to start with the equality that has the units in it that you know. You know pounds. There's only one equality up here that has pounds in it, this one, so we're going to use that one. And remembering our want to know device as to how to set up that fraction, we want kilograms and we know pounds. Yes, I know ultimately we want grams, but we are going to need to get to kilograms before we can get to grams. So we know pounds and we're going to want kilograms. As a result, 1 kilogram goes on the top and 2.2 pounds goes on the bottom. Alright, so at this point you could go ahead and solve that, and that would tell you how many kilograms there were in 10 pounds. And you do that by setting that over 1 and multiplying fractions. However, you can continue setting this up as one step as opposed to doing out two separate steps. So let's do that. So now we have pounds times kilograms divided by pounds. This is on the top, this is on the bottom. So pounds divided by pounds equals 1. It cancels itself out. Now we're in units of kilograms. We don't have an answer yet, but that's okay. We now know we're in kilograms. So we can set up another fraction with the last equality, the one that we have not used yet. We know kilograms, we want grams. So grams are going to go on the top, and the kilograms are going to go on the bottom. Top, bottom, cancels out. Now we're in units of grams. So now we can do the math and just see how many grams there are in 10 pounds. So multiplying fractions, 10 times 1 times 1,000. So we have 10,000 on top, and 1 times 2.2 times 1 on the bottom is 2.2. And our units, everything is canceled out except for grams. And 10,000 divided by 2.2 is 4,545 grams. So that's our answer. Lastly, we need to round our answer to the proper number of significant figures. We have 4, so that means we just, up here we started out with 3, so we need to round so this digit is significant and that one's not. As this number is 5, we're going to round up, so we are going to round this number to 4,550, no decimal spot, grams. The decimal spot is absent, so we would read from right to left. Ignore the non-zero digits that are leading. 1, 2, 3 significant digits, just to check our work. And that's it. So, just as a quick summary, when you are setting up factor label conversions, whether you're doing one step or 2 steps, the key to setting it up is setting up these fractions properly. And that is with want to know in setting up the units. As always, if you have any questions or are confused about part of this, please just rewatch the portion of the video that you need more help on. Right?